using some of these principles. And what we did was an implementation of inline reference monitors. And if you're not familiar with inline reference monitors, don't worry about it. I think I'm going to give you everything you need to know about IRM here. Basically, what we want to do is take a target program of unknown quality. Now, for our purposes, and because it was easy, we'll take programs written in Java or .NET, and we want to retroactively add security controls to them. That's the idea. How are we going to do that? We're going to do it with a rule-based system, because for people like me who've thought about static analysis for way too long, everything turns into a rule-based system. In order to activate code that we add to the system. So the rules define a set of monitors. Those monitors watch places in the program that we call program points, and then generate events when interesting stuff happens. Now what do you do when something interesting happens? Well, I don't know what you want to do when something interesting happens, so I give you a way through a set of event handlers that are externally defined to either stop that action or log that action or make a correction to the state of the program. You could do something like write to syslog, write to a log file, or actually interfere and alter the state of the program. So this is the basic architecture for the inline reference monitor system that we built. And now I'm going to give you, 7 or so examples of things that we did with this system and try and inspire you to go think about how you could get good at coming from behind, retrofitting code, and learning to live with the state of security that we have today rather than expecting it to evolve overnight. Okay, so first thing we can do is mitigate vulnerabilities. Let's say you've got a target program and it's got a SQL injection vulnerability in it. That means there's some attacker out there that's going to launch some sort of malicious input at the program. If you use a web application firewall, which is of course just going to watch the network, then they're going to defend out here. We can wait until that program assembles a query and then look at that query and say, did this take some input, move it into the SQL query, and does that input actually change the syntax of that SQL query? If so, that looks like an attack. So we can use information from the internal state of the program in order to defend against SQL injection and block attacks that a network-based approach never could. We can also do things that just simply don't take place on the network. For example, data masking. So you've got a user, they're not doing anything malicious necessarily, but somehow their credit card number or social security number are ending up in the log file. Well, that's a bad deal. So you could either send that back to the developers and tell them, hey, you can't do that. Your logging looks like this. And it turns out that, yeah, we weren't supposed to use that field for credit card numbers, but now we do, so you need to modify things. Or we can simply watch exit points and say, oh, look, you're writing to a log file. Oh, look, the data that you're writing out hashes like a credit card number or matches the format of a social security number. And then we can block or mask that data as it's written out. Much easier than sending that code back through a development cycle and easy to change on the fly. Next, we can provide security intelligence so that people know how their system is being used and abused. So here's a malicious user who's probing for corner cases. We can start counting up failed access attempts and give you a map about where they're probing or the kinds of things that they probed last. So you, of course, can do all of this stuff. If you, say, adopted a SAPI, then you could start building in this kind of intrusion detection system. But that, again, requires you going and convincing the software developers to do things differently. In the long term, that's a good thing to do. In the short term, being able to retrofit your code with security protections is a really good deal. Next up, not only can we spot vulnerabilities, we can patch them live, which means you don't have to take your system offline. If, say, by watching what that attacker was doing to your access control system, they're sending unauthorized requests, you want to start making a connection between a user role and that unauthorized request, we can connect that stuff up and start denying those unauthorized requests without taking your system offline. That's a really good deal. Boy, when you start talking to developers about security stuff, they say, I don't know. And what they really mean is, how much does this cost? Are you asking me to write you a blank check? Like, do you understand I have uptime requirements? those kinds of things. If you tell them, I don't have to interfere with your uptime requirements, then all of a sudden, they'll let you play to a much larger degree than they would before. I want to make another comment about Microsoft here. I put up Bill Gates earlier. Microsoft is actually pretty darn good at patching these days. Why? This is something I tell my 4-year-old all the time. How do you get good at something? Practice, right? Yeah? It actually makes them very, very good. They're very good at patching. They got patching down. They used to patch entire systems. Basically, a patch to Windows was a replacement for Windows. They don't do that anymore. They give you the smallest patch they could. Why? Because that helps them, it helps you install it, it helps them test it. They're very surgical about their patches. So, and now if you don't have to, if it doesn't require a reboot, they're not going to force you to reboot. So get good at patching. Okay. Here's, I think, my favorite of the whole bunch. Here's a problem you may have encountered before. You come across a cross-site scripting vulnerability. And this is like the most canonical cross-site scripting vulnerability I could think of. It's just you took something off of the URL and you spit it right back out onto the page. It's JSP syntax. So you go to the developer and you say, you can't do that. You say, well, why can't I do that? And you explain, well, here, you know, blah, 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 OWASP top 10, blah, 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 gonna exploit you, all that. And they're like, oh, okay. Well, then I'm not going to do that anymore. So how do I fix it? What do I do instead? And then you say, well, that depends. That depends on what you're writing out here. Maybe you ought to do this, encode HTML. So did that fix the vulnerability? Maybe. Maybe it fixed the vulnerability, or maybe it didn't. Because maybe that write statement was in the middle of a cascading style sheet, in which case you encoded the wrong thing. And if you start writing down all of the advice you need to give a software developer about how to prevent cross-site scripting, it actually turns out to be pretty lengthy. And now all of a sudden you say, oh, silly software developer, you put another cross-site scripting vulnerability in your code. Now let me send you to a one-day class on how to avoid cross-site scripting. Oh, forget it. How are they ever going to get that stuff right? What we really want is a context-sensitive method named encode that knows how to do the right kind of encoding for the situation you find yourself in. Well, guess what we can do if we can monitor that program? We can take that encode method and do a different thing because we watch what's being written out to the web page, and we can have encode mean different things in different contexts. All of a sudden, we can take a really hard programming job and turn it into a really easy programming job. This is the one that looks the most to me like preventing buffer overflow, so it's the one that I'm most excited about. Collaborating with software developers to make the process of creating secure code easier. Okay, 2 more. The first is improving penetration testing. So, if we're inside the code and if we can see vulnerabilities as they're tickled, then we don't have to rely, when we're doing penetration testing, on just what comes back out via HTTP. In other words, we know when the program has been attacked and when it's found a vulnerability. And that means we can do a better job of providing penetration testing results. For a while, we didn't know what to call this. Eventually, we called this Hybrid 2.0. And got together with our buddies at HP, and they're very good at putting out press releases, so we did a bunch of that. But the basic trick is watch what's happening inside the code so that we can report not just what the attack is and what came out via the HTTP stream, but also how the software reacted to the attack. And then, of course, you can use that to link up against static analysis results if you like, or just give a developer a stack trace that says, here's the part of your code that's broken.